the two minor arcs are congruent if their corresponding chords are congruent. So this says that if we know that AB is congruent to CD, then we can conclude that the arc AB is congruent to the arc CD. Just like when I cut that circle. And that also works in the other directions. If we were told that the arcs were congruent, we could conclude that their chords would be congruent to each other. On here. We'll get your circle O. And B will be our radius, and we'll the chord A. Yes, AT is the chord. So if OB is perpendicular to AT, we have a 90-degree angle here, then we can conclude that A to the middle here, let's call that R, then AR is congruent to RT. It bisects this chord. And similarly, the arcs are also going to get bisected. So AD, arc AD is going to be congruent to the 9-4 arc. So these are the two theorems that we're going to utilize in some problems today, okay? Eastern to the circle, we have two chords. This is a chord, and then this is a chord, are congruent, so their arcs have to be the same according to the first theorem. So we know that the arc over here on the left-hand side would also have to be a 4x. The three arcs are simply outlined here, and how many degrees in a complete circle? 360. So we're going to write that as an equation. 4x plus 4x plus another x is equal to 360. Combine like terms and solve. 4, 8, 9 x's. Let's find the measure of those three arcs. So the one down here at the bottom would be 40. The one over here on the right, 4 times 40. And then if you want to check and make sure 160 plus 160 plus another 40 should give you 360 degrees of same circle. Example 2, I want you and your partner to discuss example 2. Think about what does it mean to be a regular polygon or a regular quadrilateral. So we have a regular quadrilateral. All sides are the same, all angles are the same. And in relation to the circle, AB is a chord, BC is a chord, CD is a chord, and AB is a chord. So for those arcs should all be the same. Now my diagram is not drawn real well, but These little imaginations for so much. Okay. All these arcs should be the same. So how could we find one of them? Oh, inside? Yeah, that's true. Okay, I can put that in there. Okay. What about the arc? What would be the measure of arc AD? Ah, 360. What about that for? There's all four of them. So each one of these arcs will also be 90 degrees. What if instead of a quadrilateral it was a hexagon? A regular hexagon inside that circle. How would you find the arc measure? If it was a hexagon. Develop it. Six-sided. So each one of the arcs would have been 60 for a hexagon. What if it was, I don't know, what if it had 100 sides? How would you find the arc measure? So we're going to put 360 divided by the number of sides. Now that only works if it's a regular polygon. Only if it's regular now. Question to start out with. And it says the radius is perpendicular to the chord. So that's why I have this little 90 degrees. Okay. And the chord is 24 inches. If the measure of arc CD is equal to 134. Part A says find CD. Part CD. So they call it this whole arc. 134. According to that second theorem we wrote down, if we've got a chord and the radius is perpendicular, the arc gets bisected as well. So we're going to put 1/2 of 134. So it's 67. Which one of these will be 67? All right, part B says that we want to find OX. I'm going to draw an auxiliary line to show this out with. I'm going to draw a line that goes from O to G. This 90-degree angle, this vertical angle would also have to be 90, so I can put a 90 in there. We're trying to find OX. It tells us in the directions that the chord CD is 24 inches all the way across. According to the theorem, if we've got a perpendicular, this gets bisected. So how much is it from X to G? Okay, OG, we need to figure out what that is. Can we figure out how long it is from O to G? Is it a chord, a radius, a diameter? It is a radius. OD is a radius. Any point on the center to the outside of the circle. What? Because XD is 12. And OD is a radius, and so it would have to be 13. Put 13 here. And now, look here. Magic happens. Here's a right triangle. How do we find the third side of a right triangle? Yep. So we have, let's see, which one's the hypotenuse in that yellow triangle? 13. Okay, so we have 12 squared plus, we don't know squared, equals 13 squared. 69. So b squared is 25. So we get 5 up here. Background knowledge, right? Okay, we're going to do one more. Any questions so far? Because that's kind of hard. It's a lot of pieces. We're looking for an angle of a right triangle. Use your background knowledge. Discuss a possible plan with your partner to find this angle. I'll give you like a minute and a half to decide. For example, if we wanted to do sine, we're looking for an angle, so you have to use the inverse key. If I'm here, the opposite side, 5, over the hypotenuse. And then you could type that in your calculator to get your angle. I think it's 22 point something degrees. Would somebody type that in for us? Make sure you're in degrees. I think it's 22. Did you all get it typed in? Oh, okay. 22.6, okay. 22.6 degrees. You could have done cosine. You could have done tangents. Any of the three would have worked out for us.